Bismillahirrahmanirrahim. Assalamu alaikum. I'm Dr. Sajid Khan. Today, the topic of our lecture is application of derivative. You know that derivative is rate of change of a dependent quantity with respect to independent quantity or variables. First of all, I discuss some important concept, a mathematical concept related to derivative, and then discuss some physical problems. Yeah, what is increasing, decreasing, and constant functions? You know that let f be function defined over some interval I, and we have some two variables x1, x2 belongs to that interval. If f of x1 is less than f of x2, means that when we increase input from x1 to x2, function value is increases from f of x1 is less than f of x2, means that function values increases with the increasing input, and decreasing function is what? When f of x1 is greater than f of x2, whenever x1 is less than x2, which means that when input is increases but output is decreasing, function value reduces with the increment of input. Understand? And the third one is a function is a constant function in the case when f of x1 is equal to f of x2 for all the values of x1, x2 belongs to that interval. For example, you have clearly seen from these two figures, increasing means that when input is increasing, you know that from left to right function values increases. Input is increases and the function values also increases now in this case, because graph grow up means that f of x1 is less than f of x2. So x1, x2 are any two variables from this interval. So when increasing input gives increasing output, it is basically increasing function. And the second one is when input is increases from left to right, function values decreases. Now f of x1 is basically greater than f of x2, which means that function value decay, and in that case we called it as decreasing function. And the third case is what? You know that when x1, x2, any two value over the x-axis, you know that is x-axis and it is basically y-axis. And if the graph is parallel to x-axis, which means that function value at two different locations, x1 and x2 function value is same. So for all input, if function value is same, output is same, in that case graph must be parallel to x-axis. So it is known as a constant functions. So these are basically different types of functions, increasing, decreasing, and constant functions. And it is basically graph of y is equal to x cube. You know that what is the domain of x cube? Domain is set of all real numbers, and range is also set of all real numbers, and you are familiar about this graph. And you know that from minus infinity to plus infinity, minus infinity to plus infinity, it is basically the direction from minus infinity to plus infinity. Function values increases, you know that from negative to approaches to zero, and then to towards positive y-axis. So for all the values of input from minus infinity to plus infinity, function value is increasing. So f of x is equal to x cube is basically increasing function over all the interval from minus infinity to infinity. Similarly, now in this case, it is basically a different function, and you have seen clearly from the graph that from minus infinity to 0. From minus infinity to 0, when input is increasing, function value is increasing and approaches to 0. But after crossing origin from 0 to 1, with the increasing value of input, increasing value of x, output is decreasing. Now in this case, graphs uh, down towards the value of y, which is equal to minus 1 by 2. So from 0 to 1, function value is decreasing. So here we call this function is a decreasing function for the interval from 0 to 1. And after the point 1 minus 1 by 2, again function value grow up, and with the increment of input, function value is increasing and grow up to plus infinity. So here our input is basically again cubic function have the set of all real number as input. So now in this case we have three types of intervals from minus infinity to 0, 0 to 1, and 1 to plus infinity. So from minus infinity to 0, our function is an increasing function, and from 1 to plus infinity, function is an increasing function, but from 0 to 1, function is an decreasing function. And the second concept, which is related to, directly related to derivative, and with the help of derivative, we easily classify the minimum and maximum values of the function. Minimum and maximum values of the function mathematically, if f of c sees any value from the interval, from the input, and this value is maximum value, if this condition is satisfied, it means that f of c must be greater than or equal to f of x for every x and in the input, and f of c is the minimum value if f of c is less than or equal to f of x. So what is the concept of f of x is equal to f of c, which means that maximum value over all the interval I is a unique value, but location is not unique. If f of x is equal to f of c, it means that we have two input where function value is the maximum value. So maximum value over any interval is a unique value, but that value exists over the different locations. That's why here we put equality sign if f of x is less than or equal to f of c. So it is basically general graph of a function f of x, and over the c you know that this value is a maximum value. And other concept is here derivative of function is equal to 0, which means that, and what geometrically derivative is basically slope of the tangent line. Now in this case, tangent line is parallel to x-axis, so its slope is equal to 0. So maximum value occur where derivative is equal to 0. And the second one is the important concept, when the derivatives are undefined, then also there is a chance of maximum value. So it is basically general function, and here f of c again function derivative of function is equal to 0 here, which is parallel to x-axis, and f of c is a minimum value easily seen from the graph. Function value at f of c is less value from all other values of f of x. And what is the concept of local minimum, maximum, local extreme values? Basically, in the previous slide, we discussed about the function value over the entire interval, but local extreme values means that the function value in short way, function value must be greater than or less than from the neighborhood values. Then it is called as local extreme values. Extreme means that maximum and minimum. So local maximum value is what? When f of c is greater or equal to f of x for all x in a b. Basically, it is open interval. It is basically neighborhood of c. So in short way, what is the difference between global or absolute extreme values and local extreme values? Local extreme values means that function values minimum or maximum from the neighborhood values only, but absolute maximum or global maximum or minimum means that function value is small or large over the entire interval, over the complete domain. So it is basically a difference between extreme values, local and global. So it is basically journal sketch where you have easily seen that here is a local minimum value. Local minimum means that over the at number C, if here is number C, we put here C. So at a value is its value, function value is a minimum, and over the neighborhood function value is greater than this value over the both sides, then it is known as a local minimum value. Similarly here, function value is a local maximum value. Similarly here, it is basically, it is different nature of the graph. Here there is a corner means that derivative does not exist. So where derivative equal to 0 or derivative is undefined, so it is basically an important concept of critical numbers. In the next slide, we have properly discussed or defined critical numbers. So here basically local minimum value again, and here is local maximum value. Okay, for example, if we put here a point, so it is basically cross over this particular position. So is there is any minimum or a maximum value? No. Answer is no, because over the one side, over the left side, function value is greater than this particular value, and on the right side, function value is less over this particular position. So it is not any extreme values. So for our extreme values over the neighborhood left side as well as over the right side, function value must be greater than that particular position or must be less than from that particular position. Then that point, that position becomes a local extreme position or local minimum position or local maximum position. Understand? So it is basically important concept of critical numbers. So important note is what? First of all, here a function value is maximum or minimum over the open interval, then derivative must be equal to 0 or derivative does not exist over that location or that position. So where derivative does not exist or equal to 0, it is known as critical number. So simple way, what is the definition of critical number? So definition is basically a number C where in the domain of the function, that is very much important concept. This number must belongs to the domain of the function, and then derivative must be equal to 0 or derivative does not exist over that particular input. So how to calculate critical number? It is very much simple. Just take the derivative of given function and equate equal to 0. Then you can clearly identify the values of the derivative where derivative is equal to 0 or undefined. Now it is basically guidelines to calculate the global or absolute extrema or extreme values over the closed interval from A to B. And it is a very important concept over the closed interval, mean over the entire interval. So these 4 points are very much important. First of all, what is our job? First of all, our job is to calculate critical numbers. And how to calculate critical number? Take the derivative of the given function. Take the derivative of given function and equate equal to 0. When derivative is equal to 0, then you can easily identify the value where derivative is equal to 0 or undefined. After that, calculate the function value over that number. And secondly, calculate the function value over the boundary points A and B. So overall, it is difficult to check at each and every point over the interval function value is impossible for us for each and every location of that interval, even if we take a smaller interval from 0 to 1 even, but there are infinite many numbers from 0 to 1. So it is impossible to check each number, put in the given function and check the output. So what is the chances of extreme values in the interval except A and B? So except A and B, A and B is these two are the boundary points, and it is easily to calculate the function value at A and B. And where extreme values exist other than A and B, so only over the critical numbers. Only over the critical numbers, as we discussed in the previous slides. When derivative equal to 0, then we have to find critical numbers. After calculating critical numbers over the function f and then calculate the function value at A and B. So we have function values over these particular inputs. After that, judge or classify or identify the function value. Largest value is the maximum value and the smallest value is the minimum value of the function calculated in number 2 and 3 points. So in short, our job is to calculate critical numbers, function value over that critical numbers, and function value over the number A and B. Largest value is basically maximum value and the smallest value is basically minimum value of the function. So it is the basically example, mathematical example of this concept. Now in this case, our job is to calculate the function value of f of x is equal to x cube minus 12x over the interval minus 3 to 5. So first of all, take the derivative. It is very much simple by using the power rule. 3x square minus 12 is the derivative and after simplification, we have two factors x plus 2x minus 2 and must be equal to 0. And 3 is not equal to 0, so equal to 0 is x plus 2 and x minus 2. We have two critical numbers plus minus 2. And now in this case, we have four inputs. First, minus 3 and 5, and the second one is critical numbers. These numbers are plus minus 2. So next step is what? Calculate the function value over these four inputs, minus 2 and plus 2, minus 3 and plus 5. So function value over these inputs are 16 at minus 2, 2 gives minus 16 and minus 3 gives 9, and at x is equal to 5, function value is 65. So it is basically largest value among these values, which is known as a maximum value, and minus 16 is basically lowest or smallest value among these values. So it is known as a global minimum value, because over the entire interval minus 16 is the minimum value and 65 is the maximum value over the entire interval. and you can easily see these two equations over the graph. It is basically first location absolute minimum value, which is 60 minus 16 at x is equal to 2, and the second one is at x is equal to 5. Function value is basically 65, or this location it is basically 65. And for what is the important for sketching the graph of the given function? First of all, put these four numbers over the Cartesian plane. Horizontal axis x-axis and vertical axis y-axis. First of all, put these 4 points. Understand? These 4 points, -3 and -2. We have the function value is 16. And here at x is equal to 2, function value is -16. And at 5, function value is 65, and at x is equal to 0, you know that where the graph passes through y-axis, simply put x is equal to 0 in the given function. Here when x is equal to 0, y is equal to 0, so graph passes through the origin, and it is basically smooth turning. It is very much important how to passes the graph over the location -2, 16 and 2 minus 16. These two locations are basically smooth turning location because derivative is equal to 0 at -2 and +2. When derivative is equal to 0, so there is a tangent or these two locations must be parallel to x-axis, because slope of tangent line is equal to 0 when tangent line is an horizontal line. Understand? So it is basically graphical view of the given function with the absolute minimum and maximum value. Now, you know about the terminologies and daily life. What is greatest profit, least cost, least time, greatest voltage, optimized size, least size? So these are basically common terminology in daily life usage. So how to optimize, how to check the minimum or maximum cost, profit, voltage, size, least time, least cost, maximum profit, maximum loss. So these concepts are easily visualized with the help of application of derivative. So you have seen this example. A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. We have a flat sheet whose surface area is 108, and our job is to calculate the dimensions of that sheet will produce a box with maximum volume. So in simple way, what is our objective? Objective is made or design open box by the sheet whose surface area is 108 square inches. Understand? And second constraint is what? We have a square base only. So first of all, if we calculate the dimensions of that box mathematically, and after that we construct or made that box, so it is easily for us to accommodate a maximum volume over that entire open box. So how to calculate? Now in this case, we have the information. So it is basically a sketch of that open box whose base is basically square base. So each side is represented by a variable x. and height is represented by a variable h, and you know that what is the formula for overall the surface area of that box 108, and how to write 108 is equal to x square plus 4xh. Basically base is a square base and one side is x, and how to calculate the area of the square base, you know that it is basically x square. Okay, and how to calculate, because it is a square base have the area which is equal to x square, and how to calculate the surface area, you know that height have four surfaces, and area of one surface is basically h multiply with x. It is basically gives this front face of that open box, and it has area of xh. Similarly, xh of the rest C. So overall 4xh is basically area of the sides of the box, and base have x square. So overall combination of x square plus 4xh is equal to 108. So what is the primary equation? Primary equation basically our objective equation. Objective function is what? Our job is to calculate the volume. So what is the formula for volume? Area of the square base, which is x square, and height is h. So volume is calculated by the formula x square h, and it is known as a primary equation, basic equation, and the second equation is what we have the surface area, which is x square plus 4xh. Understand? Now it is a very much important secondary equation, because our objective function have two variable on the right side, x variable and h variables. And here we know about the concept of a derivative where the independent variable is a single variable, because it is basically related to single variable calculus. So first of all, using secondary equation to calculate the value of h. So simply x square plus 4xh is equal to 108, and we have to calculate the value of h from this equation, which is 108 minus x square over 4x. Understand? It is very simple mathematical calculation. Shift x square towards right side and then divide throughout the equation by 4x. We get this one. And when substitute this h in the given primary equation, we get the value of v function, which is equal to 27x minus x cube over this one. So it is basically our now a function which is in convenient form. V depends over x, which is basically function of one variable. It is our basic objective to convert the variables in the single variable form. So h is converted into variable x form. So v is equal to x. Now second one is what is our objective? What is the domain? What is the feasible domain? Feasible domain means that acceptable domain according to the situation, physical situation is what? So according to physical situation, our area of the base is basically x square. Understand? So overall, the value of our sheet is area of our sheet is 108. So x square must be less than or equal to 108, because if there is no height of that sheet, so base have maximum area of 108. So ultimately x have the range from 0 to square root of 108. It is basically feasible domain. So how to maximize V? First of all, our job is to calculate the critical number. As in previous slides, we have discussed about the extreme values, and where extreme values exist over the critical numbers. So first of all, take the derivative of the previous equation, which is basically 27x minus x cube over 4. Again, it is a very simple function. So they have the derivative 27 minus 3x over 4 by power rule and equate equal to 0. We get the value of x which is equal to plus minus 6. And here you know that feasible domain is from 0 to square root of 108 and x is the length, so it is basically only positive value. So ignore negative value and we pick here only positive value. Now next one is here. We have discussed in the guidelines of how to calculate the absolute extreme values. So here we have 0 as a first boundary of this interval and second boundary is a square root of 108 and a middle point is what means that from A to B middle point is basically critical number and critical number is a 6. Now substitute 0, 6 and square root of 108 in the given function. V is our given function. So here in V 27x minus x cube over 4 when substitute x is equal to 0 our output is 0 and at square root of 108 again our output is 0 and but when we substitute a value of input x is equal to 6 v is equal to 108, so it is basically maximum volume. So what is the value of x? Now in this case x is equal to 6 and simply by substituting that value in the relation, here we have the relation when x is equal to 6 h is equal to 3. Now h is equal to 3 now in this case. So what is the dimension of the box? Dimension of the box is 6 cross 6 cross 3. When we made the box of this dimension, we have to accommodate a maximum volume of 108 square inches. Understand? If roughly, what is our observation? If we have take the any other value of x just like as 5 less than 6, 7 greater than 6. So when we take the value of x other than 6 from 0 to square root of 108, you know that square root of 108 is basically 10 point something. So take any value of x, we have the box, but that box does not contain a maximum volume. So we have shown you some examples of this concept here, you know that. Now in this case, in first open box, if we take the value of x is equal to 3, then 3 cross 3 multiply with 8 into 8.25, we have 74.25 as volume, which is less than 108. Secondly, if we have x is equal to 6, when x is equal to 6, h is equal to 5.75. Now in this case, we have the volume of 92 square inches. And similarly in this case, but all these values less than the value of 108. So 108 value is basically our maximum value, which is at x is equal to 6 and h is equal to 3. So it is basically a reasonable size. In the appearance, it is basically a flat open box which does not have the maximum volume. When we take the value of x is equal to 8, our output is basically 88, which is less than 108. So important is what? Important is to first of all calculate the mathematical calculation about such problems where our job is to optimize the situation either toward minimum side or toward the maximum side. We get the useful information. So overall, when we solve such problems, we have these guidelines. What is guidelines? First of all, identify the given quantities and all quantities to be determined. If possible, make the sketch and then write the primary equation for the quantities which is to be maximized or minimized, and then reduce the primary equation in the one variables independent variables with the involvement of the secondary equations. After that, identify or determine the feasible domain of the primary equation and then determine the values over which the stated problem makes sense. Understand? So physically, feasible domain means that you have the range of the input and determine the desired maximum minimum values by the calculus techniques we have discussed in the previous slides. First of all, take the critical numbers. After that, calculate the function value of the critical number over the endpoints. Then you have easily judge about the extreme values. So thank you so much for listening me. Allah Hafiz.